Hi everyone, this is Mrs. GA, and today we're going to talk about the laws of logarithms. So there are three main laws of logarithms that we're going to be using today. So first, let's assume that a, lowercase a, is a positive number that is not equal to 1. So notice that's where the base of our logarithm. And let's let a, b, and c be any real numbers, and a and b must be greater than 0. Okay, so the first law says that if you are taking the logarithm of a product, meaning something that you're multiplying, you can expand that into two separate logarithms using addition. So notice the single logarithm turned into two separate logarithms. The base stayed the same, except the two numbers in our product are now separate. The second law says that if you are taking the logarithm of a quotient, like this, we can expand that into two separate logarithms using subtraction. So the key thing to remember here is that any number that was in your denominator becomes a negative logarithm. So we could actually write this as negative log base a of b plus log base a of a. It doesn't have to be in this order, but this logarithm must be negative. And last, if you are taking the logarithm of a term being raised to an exponent, we can take the exponent and actually move it to the front of our logarithm. So this is totally legal to do, but only with logarithms. So this, and we can go vice versa. If you see an or a coefficient here, we can move it up to the exponent within our logarithm. So we're going to see if we can use these three laws to help us maybe rewrite expressions in ways that might be a little bit easier for us to evaluate or understand. All right, so let's give these a try. And again, we're going to see if we can use one of those three laws to make it a little bit easier for us to evaluate these expressions. So here I see a sum of two separate logarithms that have the same base. So using law number 1, I can actually condense it into a single logarithm, and I'm going to multiply 2 and 32. And if you look at this, I can move backwards and it would result in this. So this is that first law we just talked about. Well, then we can simplify this. So log base 4 of 64, and then this is something that's easy for us to evaluate because we know that 4 cubed is 64, so this becomes 3. And again, the reason for that is because 4 to the third power equals 64. Remember, logarithms define exponents. Okay, let's try the second one. So again, this may not be something that I can evaluate the terms separately, but let's see if we can use that second law. Since I see subtraction, I'm going to condense this into a single logarithm, and I can do that with a quotient. So notice that the base does need to be the same for us to do this. So now I'm just going to do a little bit of division here, and then we'll get something that we can actually simplify pretty easily, because we know that 2 to the 4th power is 16, so this logarithm becomes 4. Again, the reason for that is because 2 to the 4th power equals 16, and logarithms define exponents. Okay, for this last one, let's see if we can use that third law. So I'm going to take this coefficient and I'm going to move it up to the exponent of 8 just to see if it helps us simplify. So we know that this means log base 2 of 1 over 8 to the 1/3, right? Negative exponents cause a reciprocal action, and we know that 8 to the 1/3 just means cube root of 8, which is 2. Now this is something that I can evaluate. I know that 2 to the power of -1 equals 1/2, which means that this logarithm is equal to -1, because again, logarithms define exponents. All right, so see if you can pause the video and give these two examples a try. See if you can use one of the laws and then evaluate. All right, so here, be careful with this first one. So remember, anything that was positive will be multiplied and anything that is negative will be divided. So it doesn't matter what order it is. All I know is that since log 2 is negative, the 2 goes in the denominator. So if you simplify this, we get log of 100. And remember, this is a common log, so it's implied that the base is 10. So this becomes 2. Here, move your coefficient to the exponent. Log base anything of itself will always equal 1. All right, so now we're just going to practice expanding and condensing a little bit more. So first we're going to see if we can expand these as much as possible. So here I see a product. So I know that I can turn this into 2 separate logarithms, both base 5, like this. But then we can also expand this a little bit more by moving our coefficients, our exponents to the coefficient. So this becomes 3 log base 5 of x plus 6 log base 5 of y. And this is fully expanded. All right, this next one, we have natural log of AB over cube root of C. So we're going to expand this into 3 separate logarithms. So here, natural log of A plus natural log of B plus because it is in the numerator and it's a product. And then since cube root of C is in the denominator, we're going to turn that into a negative logarithm. So negative natural log of cube root of C. Let's rewrite cube root of C like this, C to the 1/3, and then we can move that exponent to the coefficient, meaning we are fully expanded. And there you go. So we were able to expand a single logarithm into 3 separate logarithms. All right, so now we're going to try to do the exact opposite, and we're going to see if we can condense this expression into a single logarithm. So I'm going to do this methodically. I'm going to start by moving all of my coefficients up to the exponent. So before I do anything else, I'll do that as my first step. So minus the natural log of z squared plus 1 to the 4th. And we can even take one more step and write this as the square root of z. Okay, so now I want to take these 3 and turn it into a single logarithm. So it's a really common mistake I see that when in the process of condensing, we write the actual logarithm more than once. When you condense, you should only have this written one time. The rest is just a matter of what's going on within the logarithm. So since these first 2 are positive, I'm going to multiply them together like this, and they will be in the numerator. This logarithm is negative, which means that this will travel down to the denominator. So it becomes z squared plus 1 to the 4th. And now I have condensed it into a single logarithm, so I am done. The one to watch out for is this -1. Okay, see if you can pause the video and try to expand part A and condense part B. Okay, let's check your work here. So when we're expanding, we should have a separate logarithm for A, square root of B, and C to the 8th. And then it's just a matter of creating an exponent and then moving our exponents to the coefficient. Make sure natural log of C to the 8th is negative. For part 2, first we're going to move our coefficients up to the exponents. I like to rewrite this as a square root. And then since everything is positive, we just multiply together within a single logarithm. All right, the last thing we're going to talk about is what's called the change of base formula, and it looks like this. Log base b of x can be written as common log of x over common log of b. And in fact, you can pick any base you like. You could write this as natural log of x over natural log of b. You can even say log base 5 of x over log base 5 of b. It doesn't matter. But what you do need to note is that x will go in the numerator, and your base b becomes part of the logarithm in your denominator. So why would we ever want to use this? I think the main application, at least for us, will be so we can get a decimal approximation with a calculator. So the problem is most calculators are not able to do any base of log. They can only do specific ones. Most can only do common logs or natural logs. So if you need a decimal approximation of something like this and your calculator isn't a fancy one that can do any base, you'll have to just use this change of base formula so you can plug it into your calculator. So just real quick, I want to show you how this works. If you have log base 8 of 5 and you want a decimal approximation, you could just write this as log of 5 over log of 8. So that's common log of 5 over common log of 8, which just about any scientific calculator can do. And then we can get a decimal approximation. This one becomes approximately 0.77398. And then one more example, this we could always rewrite as, well, let's try natural log. Natural log of 20 over the natural log of 9. Pretty much all scientific calculators can also do natural log, so that's a useful one to be able to rewrite. And so that gives us 1.36342. So again, our main application of the change of base formula will simply be to we'll use it to plug it into a scientific calculator. Unless your calculator can do something like this, then you can plug this in and get the same exact answer. All right, that is all for today's video. Thank you so much for watching.